Okay. The lead-in that you see in your warm-up here is a wonderful lead-in to our notes today. What we are going to be focusing on over the next couple weeks is dealing with simplifying trig expressions, verifying equations written in terms of trig expressions, leading us into being able to work with equations written in trig, okay? And so kind of the foundations to eventually solving functions written with trig equations in them. So we're laying the groundwork right now. And part of that is this warm-up. And this warm-up is actually a section that our book kind of skipped over, but a good way to kind of lead into what we're talking about today. One of the things you can look at is what these all were. And we talked about what these were in terms of sines and cosines when we were talking unit circle values, because I would go find my cosine value and divide it by my sine value to get my cotangent. Well, today we're not getting actual numbers. We're just still talking in terms of sines and cosines, etc. When we see something like this, though, it is similar to something like 1 over a times a over b, where the a's would cross off, and our trig functions behave just like a variable would in that sense. Okay, so as I see this, I see a cosine here in the bottom and a cosine here in the top, which would simplify, right? Leaving me with multiplying straight across the top, straight across the bottom, 1 over sine of x. Now, depending on where you're headed, I do want to point out 1 over sine of x was also the same as another trig function that we knew. What is 1 over sine of x? Cosecant of x, right? That was one that we knew. So you could see it written this way, or you could see it written as the cosecant of x. Same. If you got to that point, you're doing great. Okay. So looking at the others here, again, if I were to just start by writing these as what I know they are as sines and cosines, go back to what we learned in our unit circle, tangent being sine over cosine. Cosecant was 1 over the sine of x, right? We put our sine value in the bottom of that fraction, okay? Cosine is just cosine. If I want to think of it as a fraction, so they're all fractions, I can make it cosine over 1 so that I can see what's in the top and what's in the bottom and what I can cross off, right? Well, I have a sine of x in the top and bottom, so those would simplify. I have a cosine of x in the top and bottom, and those would simplify. And I've crossed off almost everything. What does that leave us with? 1. Okay. And then not multiplication. So reminder, you cannot simplify across addition, right? So had that been cotangent, just hypothetically speaking, it was not, but had it been cosine of x over sine of x, this is not legal because we cannot simplify across an addition sign, right? So backing up, again, thinking algebraically and thinking not in terms of sines and cosines, but what if I change them to variables we know, like 1 over x plus y over x? Would we be able to put those together? When you're adding fractions, what do you need? Same denominator. And because our denominator is cosine of x in both of those, just like it is, that looks like an x, doesn't it? Y over x, we can add those together because they have that common denominator, right? And when we have something that has a common denominator, we add them together, we just keep the common denominator and we add the numerators. Well, those are not like terms, so it'd be 1 plus sine of x, right? But then we can put those together, okay? Questions for me? So that gives you a little intro actually into some things that we can do. I want to remind you that you can manipulate these things just like you would if they were variables. So think of sine of x as a, think of cosine of x as b. And what can we do, like, to simplify those fractions or add them together or whatever we need to do. And today we're going to get this introduction to identities. So we're going to start by just reminding ourselves of these identities that we knew and then adding some new ones. And then using those to verify equations. And what they're going to do is they're basically going to say these two things are equal to each other. Work with one of them and use those new identities you just learned to prove that it matches the other side. okay? So we'll get into that. Let's go to our identities cheat sheet. We're going to fill in a bunch of these identities. These ones should all look familiar, okay? Sine of x being 1 over cosecant x, and cosecant x being 1 over sine of x. Cosine of x being 1 over the secant of x, and secant of x being 1 over cosine of x. Tangent of x being 1 over cotangent of x, and cotangent being 1 over tangent. More often, we end up using things in terms of sines and cosines. So yes, I gave you an identity right now with tangent and cotangent as far as them being reciprocals of each other. But a lot of times in one of our most common strategies we will use when identifying trig identities is turning things to sines and cosines. So we definitely want to remember what they are in terms of sines and cosines as well. And that is tangent is sine over cosine, and cotangent is cosine over sine. Continuing on that identity sheet. Those are all known as quotient identities, not something you necessarily need to know the title of, but that's what they're saying is what are they in terms of a fraction, in terms of its reciprocal. Most often, again, we utilize these in the whole turning things into sines and cosines. Anyone still need this page? Okay, Pythagorean identities. Let's go, and guys, I'm going to actually end up giving you like 3 Pythagorean identities with each having then 2 other versions beneath them. Ultimately on here, we're going to end up writing like 9 different Pythagorean identities, okay? This one that you are looking at right now is the foundation of the Pythagorean identities. And if you know this one, you can find all of the rest of them, okay? And I'll show you how we get all of the rest of these as we do this. This being our most common one, make this a little bit smaller here. Okay, now I do want to, the other 2 that I'm going to put under this, we're just going to look at as like algebraically moving this equation around, because sometimes the sine and the cosine are on the same side where it says sine squared plus cosine squared. And through algebraic substitution, I could take this out and replace it with 1, right? Or the other way around, which I don't know why we would do this, but I could take 1 out and replace it with that. But what if it was like the sine squared? Okay, what is that? If I were to solve for sine squared, I would subtract this to the other side, right? So one of the other ways we could see this is that sine squared of x equals, subtract that cosine squared over 1 minus cosine squared. I could have done the same thing for cosine squared, right? So if I were to solve this equation for cosine squared, I would subtract that sine squared over, and I would have that cosine squared of x equals 1 minus sine squared x. So this is all the same equation, right? All I have done so far is just move things from right to left in our equation. But sometimes it's just helpful to have those already staring at me than have to do it each time. Okay, so bear with me as I build these others, and you may want to kind of slow play writing these into your notes a little bit so you can decide that there's not too much stuff on there so you know what you want to write. The other trig identities come again from this basic one, but again, just manipulating it a little bit. If I took this equation, and you guys know for equations, as long as I do the same thing to both sides, it doesn't change the fact that it's equal, right? So one of the other trig identities comes from taking this and dividing by sine squared. If I were to go through this entire thing and divide by sine squared of x, okay, look at the resulting equation. And the resulting equation would be our second Pythagorean identity that you would see. First of all, sine squared over sine squared is 1, okay? This is a very important thing for us to talk about. Cosine squared over sine squared. We just saw on the last page, cosine over sine, right? And if they're both squared, that means this was also squared. So cosine squared over sine squared is cotangent squared. And 1 over sine squared, same idea. 1 over sine is the same as cosecant squared because it was sine squared. Okay, so this would be your second Pythagorean identity. This is the first of those. And again, if I were to algebraically manipulate this, solve for 1 or solve for cotangent squared, the other ways that this could be handed to us. So let's solve for that cotangent squared. I would subtract 1. Or if I were to solve for 1, I would subtract cotangent squared. Same equation, just different things solved for. Okay. And finally, our last option. Make this a little smaller here. Same exact thing I did on the last one, but instead of dividing by sine squared, we'll divide by cosine squared. That's where this last one comes from. And simplifying each of those fractions. So sine over cosine is tangent, right? And since they're both squared, it is tangent squared. So this first fraction simplifies down into tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine from up above, 1 over cosine is the same thing as secant. And since it was a cosine squared, it would be secant squared. There is your last Pythagorean identity. If you were to lose this paper, forget these, you understand that it all stems from you knowing sine squared plus cosine squared equals 1. If you know that, you can come up with the other ones that are on this page. And again, if I were to do the same thing, just to have this to have on our paper to look at as we continue this, if I were to solve this for tangent squared, I would subtract 1. Or if I were to solve this for 1, I would subtract tangent squared. My only piece of advice to you is as you're doing this, as we start recognizing those show up, just be careful that you have the correct sign. Sometimes they try to trick us with something like a sine squared minus cosine squared. Well, that doesn't equal 1. Okay. So just make sure that you, as you go to replace these, that you're making sure that it matches the correct sign to do your substitution. Okay. Questions on your Pythagorean identities? Anyone still need this page? All right. Odd and even identities. Back in first semester, we were introduced to even and odd functions. And if you remember what we were introduced to with even and odd functions, it said on an even function, if we plugged a negative x into our function, the resulting function was exactly identical to the original, is that all of our signs would stay the same. Where an odd function was if we plugged in a negative x to our function, that all of the signs in our function would have switched, or we would get the negative version of the function. Well, these are functions and it is no different. What you see up here is the ones circled in the green box: sine and cosecant, tangent and cotangent are all odd functions, meaning if I plug a negative number into it, a negative x value, the result is a negative cosecant of x or negative sine of x. But the two that are even, kind of just like thinking inverse trig is the ones that didn't play by the same rules, right? Cosine was defined in a different place than sine and tangent. Well, same thing here. Cosine and its reciprocal secant are the only two even functions, meaning if I plug a negative into them, I just get the original plain old cosine of x or secant of x. When we see these show up, and I'm not going to introduce these into our work until like Thursday or Friday, when we see these show up, it ultimately means, do I simplify it to have a negative in front, or do I simplify it to just be the original positive version of that function? Anyone still need this page? Okay. So what does it mean to verify an identity? The thing about verifying an identity is, I hate to say this because some of us have some not great memories of this, but it's just like verifying when we talked about first semester. They're telling us the answer. We show the work to show that it's true. Similar to like a proof in geometry. You don't get to skip steps, okay? So what happens is they hand us this equation at the beginning. And they say, this is true, prove it. And so what we will do is we will pick one side and one side only. And what we'll do is we'll use some identities like here, secant of x being 1 over cosine, cotangent of x being cosine over sine. We will simplify that fraction to be 1 over sine of x. And then 1 over sine of x is cosecant of x. And as soon as we match the other side, we are done and we have verified that that was really an equal equation, okay? But the problem is we don't get to just be like, yep, I agree, that's a true equation. We actually have to show step by step how it is that they are equal to each other using our identities that we just wrote down on that identities cheat sheet, okay? So showing the work is the answers to our problems because they give us the equation at the beginning. So let's start. What you're going to notice today is at the beginning of each of these is I give you like a strategy. The hard part, this is what makes chapter 5 challenging. I should say specifically 5.1. Okay, it's really this section. There is no like, these are the steps follow at every problem. It takes a little bit of us maybe guessing and checking or trying out different methods. And maybe that method didn't work and I try a different method because they're all a little unique. And so what I'm going to do is I'm going to give you strategies to think about. The more we practice them, the more we'll recognize when I can use different strategies and be successful. Okay. So one of the strategies that I'm going to give you is try just changing things into sines and cosines and see where it leads. That is probably going to be your like biggest strategy you always use. Go back to this one always. Change things into sines and cosines. Now we will only change one side. I will say it's a lot easier to change the more complex looking side to match the less complex. It's a lot easier to simplify things than it is to add things into the problem, okay? So what do I mean by that? We've got cosecant, tangent, and then on the other side we have secant. Well, I would mess with the left-hand side of this equation, okay? It's gonna be a lot easier to simplify down to one trig function than it is to turn one trig function into multiples. So one of our strategy being change to sines and cosines is I would just take each of these and rewrite them as their sines and cosines. And this is very similar to what we just saw. Cosecant being 1 over sine of x. Tangent being sine of x over cosine of x. And again, remember, we can only do really one step at a time as we're verifying this. But this would be one step, changing the sines and cosines. And then I can see that I have a sine of x in my numerator and my denominator. And so that I would be able to simplify that. And now multiply straight across the top, straight across the bottom. I get to 1 over cosine of x. And then I'm trying to match this. I just have one more step, right? And that's replacing it with its identity. If you go to your identity sheet, we see, and this is really just algebraic replacing. Substitution is that I'm looking at this fraction right here. It can be replaced with this, right? It's just substitution from algebra. And so now I can replace, back to my page here, 1 over cosine of x with its identity, secant x. And as soon as we match the other side, We are done. Questions? I don't want to mislead you. They are not always that easy, but good place for us to start. Okay. All right. Another strategy, another version of that same strategy, I should say. Changing secant squared x tangent x to secant x cosecant x. Not super obvious right now which one of these is more complex. I'm going to work with the left-hand side again. I think let's talk about this one because there's a good thing for us to talk about over here. I want to stick with the idea of changing to sines and cosines. So in this one, and I'm going to try to color code so we can follow where these things end up. Secant squared of x, I can rewrite as its identity in terms of cosine, right? As 1 over cosine squared x. And that is divided by tangent, tangent being sine of x over cosine of x. Now we're going to talk algebra. If I am dividing something by a fraction, it is the same as multiplying by what? The reciprocal. And so that is something you will use a lot. My top fraction stays the same times the reciprocal of that bottom fraction. These are, again, equivalent to each other, right? Now comes the simplifying part. So keep in mind that this is like 1 over x squared times x over y, right? What are we able to simplify at this point? One of the cosines, and this is where we have to be careful. It'd be like crossing off an x here and here. You would still have 1x left over, right? Same over here. I can cross off one of my cosines, but we still have a second cosine left in that first denominator, right? So now multiplying straight across the top, and actually I don't even need to multiply straight across the top, straight across the bottom. I'm going to leave them as is because of where we're headed. 1 over cosine x, 1 over sine x, because now I can replace each of those with its identity. 1 over cosine of x is secant x, right? And 1 over sine of x is cosecant x. And understand that this would be exactly the same, and it would not matter had you multiplied it out. Can I go from here to here? Absolutely, completely the same thing, right? So understand that what we did here, it would have been the same as going from here to here. We are done. We match the other side. Questions? All right, those are the same thing. Okay. I want you to try this one a little bit by yourself here. Again, sticking with the strategy of changing to sines and cosines. Let you work a little ahead of me on this one. Depends on our situation. Most often you will use this one. If what was on the other side was like in terms of cotangent, maybe this is what we would use. But yeah, there's not an always use this one type of thing. I would more often use sine over cosine. So strategy, again, we are focusing on, because it is probably our most common, most effective method, is to change things to sines and cosines. As you guys are continuing to work, what we have to be okay with is trying out a method, not getting what we want, and starting over. Okay, it won't happen on every problem, but it will happen. And so understand that not every time you're going to be able to go directly there. Sometimes it's a trial and error, and the method I picked first is not working. Try something else. Okay, so sines and cosines. I'm going to go through and change. I'm going to work with the left-hand side because it's more complex looking. Okay, easier to do. So I'm going to go here, change to sines and cosines. Tangent being sine of x over cosine of x. Cotangent being cosine of x over sine of x. And cosecant being 1 over sine of x. Good so far? Okay. So a couple things. First of all, in the top, my cosine of x in the numerator and denominator simplify. My sine of x in the numerator and the denominator will simplify. And if I cross everything off, what do we have left? 1, right? So our numerator is 1. And then I can multiply by the reciprocal of our denominator, which is sine of x over 1. Multiplying straight across top, straight across bottom, and not needing the 1s in there, we just get to the sine of x, which is exactly what we were trying to match on the other side. Now, with this being said, here's the other challenging part of this is there is not necessarily one direct route that you would go. I didn't necessarily have to change this to 1 over sine of x. Okay, that wasn't necessary in this one. And actually not necessary in this one either, is we could have used other things. So I want you to understand that there is not just one direct route. What if I had left it as tangent, but changed cotangent to 1 over tangent? Because that's its identity, right? And left the bottom as cosecant x. With me so far? All I did was change cotangent. Okay, well, then over here, doesn't my tangent of x times 1 over tangent of x simplify to 1? And isn't 1 over cosecant x sine of x? So that's going to be part of the challenge is what if you did it this way and on my answer key that I show you did it this way? Is one more right than the other? Not at all. Okay, not at all. And so I don't want you to feel like, oh, I just went through this whole problem and it doesn't match the answer key. Guys, that's okay. Sometimes it won't. It doesn't mean you're wrong. Questions? All right. Let's keep going. Looking for Pythagorean identities. That is going to be another strategy. Pythagorean identities show up a ton. Now, what does it mean to look for a Pythagorean identity? A Pythagorean identity that will show up as something squared plus 1 or something squared. I should say plus or minus 1. Plus or minus something else squared. It's really that it's got this thing in there. Just having a singular squared term does not necessarily make my brain immediately go to Pythagorean identity. But as soon as I see that something squared attached to something else with a plus or minus, like this 1 plus cotangent squared, that's when my brain is going to go to my Pythagorean identity. Okay, so what do I do when I see something like 1 plus cotangent squared? Is I go to my Pythagorean identities and I look through my options. Is there something that says 1 plus cotangent squared on my Pythagorean identity sheet? 1 plus cotangent squared. Now, with addition, can that order be reversed? Yes. With subtraction, can that order be reversed? No. Okay, so we have addition, it doesn't matter, and it's in this order. So I see 1 plus cotangent squared. That tells me that I can replace it, substitution. I can replace it with cosecant squared. That's what I would do. So let's try that out and see where it leads us. Okay, so I have sine squared x, and I'm now going to replace this with its Pythagorean identity, which is cosecant squared. Parentheses, not parentheses, doesn't matter. It's one thing. Times, it's times, right? Okay, I'm trying to get it to be 1. Give me a suggestion. What could we do here? Keeping in mind there's more than one correct answer at this point. Switch to sines and cosines. Always a great strategy. This is already in terms of sine, so I wouldn't change anything. Okay, this one is not. In terms of sine, it would be 1 over sine squared, right? If I go to my identity sheet. One of the common mistakes, and this is a great point for us to talk about in this, is sometimes people try to switch too much stuff and like do every identity, but I would never move away from a sine to make this like 1 over cosecant, unless it's like I see that it's going to be helpful. I would slow play ever changing a sine or a cosine to anything else. Okay, go towards sines and cosines, not away usually. So I wouldn't move. I notice I did not change the first thing, but now if I think of this again as a numerator denominator, I've got a sine squared and a sine squared. Great. And that leaves me with 1, which is what we were trying to match. Now, as you're doing this, you will notice that I cross these things off. That is not necessary. You don't have to like go physically cross them off. I'm just explaining why it simplifies at this point, and you are welcome to do that. You don't have to though, okay? Any questions for me? So Pythagorean identity, the key is yes, a squared term, but attached to something else with a plus or a minus. That's when I'm going to go to that list of like 9 different Pythagorean identities and see if one of them matches it. Okay, so let's try another version of Pythagorean identities. When we are verifying, I am always going to encourage you to try to work with the side that is more complex. But as you look at this problem up here, don't the two sides kind of look like equally complex? Like there's not one side that's obviously like more complex than the other. So then how would I make my decision at this point? I will tell you that it is going to be easier to go from multiple trig functions down to 1 than it is to introduce a trig function when it's not there. So with that being said, I would work with the left-hand side on this equation because it's going to be easier to move towards one trig function than to add a trig function that's not there. So here's another way that Pythagorean identities can be used. And this doesn't happen as often as what you saw on the last page, but this does not match our Pythagorean identity, does it? The one I'm talking about being sine squared plus cosine squared equals 1, and they have a minus between them. So very close, but not the same. So here's what I'm going to do is we are actually going to look at, I don't want cosine in here anymore as I'm trying to match the right-hand side. So I'm going to say, okay, well, what can I do to get rid of this? Manipulate this so that I could replace it with something. So if I were to solve this for cosine squared, which we already did, it's on your identity sheet, right? We got 1 minus sine squared. And that says that I can take out cosine squared and replace it, substitution, with 1 minus sine squared. And so what I would do in this one is take out my cosine squared and replace it with 1 minus sine squared. Why did I pick to do that? Because the right-hand side doesn't have a cosine. And now I don't have a cosine either, right? That's why I picked that one to replace. Is now I'm looking at an equation that has only 1s and sines. And then this is again similar to like 1 minus x squared, except it's sine squared. Okay, well, those are like terms. These two are like terms. And I can put them together. If I have negative x squared minus x squared, it would be negative 2x squared. Very similar with my sines and cosines. Negative sine squared minus sine squared would be negative 2 sine squared, which is exactly what we were trying to match. Done. Questions? All right, let's keep going. Splitting a fraction. One of the strategies to doing this is splitting a fraction. We can do this. Very honestly, I would probably have gone this direction, but to talk about this strategy of splitting a fraction, notice that this is one fraction and this is 2 separate terms. To split a fraction, it will only work with a monomial in your denominator. Why do I say that? Because, well, remember that they have to keep the common denominator. So I'm pulling it back apart. I'm going to split right here at whatever my plus or minus is and give them both the denominator. Okay, so if I were to do that, I get the fraction 1 over cosine of x plus the other fraction over the common denominator, sine of x over cosine of x. So this would be a strategy that you could see used, and that is taking a fraction and pulling it back apart, keeping the common denominator. And then each of these will simplify. 1 over cosine x, if I go to my identity sheet, can also be replaced with secant x. Sine over cosine is tangent x. Done. Now, go the other way. Had I changed this to sines and cosines, it would have looked like this, and I could have added them back together to get this. So this one would not matter which side we work with, really, both equally complex. I would have gone sines and cosine strategy, which would have gotten you this line, and then you would have matched your answer, adding them together because they had a common denominator. All right, try one on your own. So our check for understanding, and then we are done. Tangent x plus cotangent x equals secant x cosecant x. If the side you pick to work with, it does not lead you somewhere that it seems to be easy to go, try a different side. So what I did is I took my numerator and I split it into the two terms, both over the common denominator of cosine of x. And actually, I think I'm going to jump in and help with this one because I think it's one that's a little different than what we've seen. I would probably go from here as my more complex side. It's a little easier usually to add fractions together than it is to split, to have a plus between them. If I were to change this to sines and cosines, okay, can I currently add those together? No, right now I would not be able to add those together. And so what I would want to do is get a common denominator. Well, your common denominator has to have all of every denominator. So it has to have a cosine of x and it has to have a sine of x. And if you remember from algebra, then adjusting your fractions based off of that common denominator. Gonna have to speed this up just a little bit here. We would have to multiply top and bottom. Well, sine of x times sine of x is sine squared. Over here, we're missing the cosine of x. Cosine of x times cosine of x is cosine squared. And then I can add them together because they have the common denominator. But what is sine squared of x plus cosine squared of x? That's your basic Pythagorean identity, isn't it? Sine squared plus cosine squared equals 1. So we can replace the numerator with 1. 1 over cosine of x is secant. 1 over sine of x is cosecant. Okay. Bear with me, okay? We will spend several days wrapping our minds around trig identities.